Do a little on a farm or something.
Oh. Well, might as well do this. Today is March the 28th, exactly 7 days after my birthday. I have now been 49 for 7 days. It is March 28th, and we are going to, for the next probably 2 weeks, be solving radical equations. I know that sounds funny, like if that was like back in the 60s or 70s, it would have been like, wow, these are totally radical. In case you've forgotten, radical is one of these. So that's just a generalized term for that symbol. That symbol can take on a lot of different values. The radical symbol can imply a square root, like in the case that I've written up here. If I stick a little number up here in the corner, now it's called a cube root. If I change it to a 4, it's a fourth root, etc. So that symbol is called a radical, and the number up in the corner, as you know, is called the index. And so let's just get that out of the way. The word radical implies that. For what we're doing, so as I was saying, this all we're going to focus on for at least the foreseeable future are square roots. And so when we talk about radical equations, that is a very broad sort of thing. But for us, quite specifically, all of our equations, at least for now, will involve only square roots. And so when you see how to solve them, understand that that isn't going to really change here for a little bit, because they're all going to be those guys. So having said that, really the best way to talk about this, there's not much meat on today's bone. This assignment, this topic is going to get more difficult throughout this week, but not today. Today's work is very light and simple. So I have 1, 2, 3, 4, 8 examples. Each one ought to take an average of about a minute. You okay, bud? Okay, so our first example is going to be this. The square root of x minus 6 is equal to 3. So, you know, what we want to do is we want to add 6 to both sides, but we understand, of course, that we can't do that because x minus 6, they are not free to move about the cabin, right? You've seen this idea before. When things are bound up, parentheses, a root sign. Yeah, sure, why not? Bye. So, as I was saying, you cannot add 6 to both sides. So when something's in a grouping symbol, which is what a root sign is, then you need to free it from the group or from the grouping symbols. How do you think we're going to get rid of that square root? Yeah, all radicals can be killed with their corresponding exponents. So since this is a second root, a square root, then we eliminate it by squaring both sides. That's how you're going to pull the radical off. So no real significant math occurs. It's pretty low level and simple. On the left side, we're just left with x minus 6. And then on the right side, of course, we get 9. And then what pops out is a real basic equation, and that is just add 6 to both sides and you get x equals 15. Now, your inclination at this point is going to be to just say, all right, I'm on to the next problem. But throughout the coming weeks, watch out. You're going to get more of those solutions that aren't really solutions. They're called extraneous, just for the record. Do you remember how like we would sometimes get answers and then we would plug them in and they wouldn't work, or they'd make bad things happen and we would cross them out, right? So that is going to start happening to you again. And the reason for that is when you start tinkering with exponents, then you introduce negatives becoming positives, which causes troubles. Yeah, man.
What if
No imaginaries, okay, buddy? We're not going to do that. No one, yeah, no, not right now, okay? It drives your classmates crazy. We just want to focus on this. So we're going to stay specifically within the real number set and just follow along here. So when I plug the number 15 back in, when I take 15 and I plug it right back up, follow the arrow, what is 15 minus 6? And what's his square root?
3.
And 3 does equal 3. So I can go ahead and box that one up and say, okay, you, sir, are a legit solution. All right, let's head on to the next one. We have negative 6 equals the square root of 2x plus 5 is minus 7. So I don't know how many instances of this we have and have yet to find, but that idea of get something by itself, you probably don't even need me to tell you this, but you know that you have to get rid of that -7. You just know it in your heart. And so if I isolate the radical, I'm going to add 7 to both sides, and I'm going to get 1 equals the square root of 2x plus 5. Getting the radical by itself isn't essential, but as you'll learn in the lessons later this week and next week, when the opportunity presents itself, you should take it. Because squaring one side of an equation when the radical is not by itself is markedly more difficult, as you'll see. So in this case, I think to myself, if I can get it to look like this, I'm taking it, right? And now I've arrived at basically the same as last time. What do we do to both sides? So I square the left and I square the right, and I'm left with 1 equals 2x plus 5, because 1 squared is, of course, just 1, right? And the metamorphosis, like, it happens really quickly. You've seen that with math, where we go from a high school level math question, and as soon as something like goes away, we just go, bam, I can solve this in my sleep. So we're going to subtract 5 from both sides, leaving us with 2x equals 1 minus 5. And then we're going to divide both sides by 2 and get x equals -2. And as has been the case and will continue to be the case, I'm going to take just a few seconds, and I'm going to make sure that that answer isn't going to cause any problems. So follow the yellow here. I'll color code for you. We're taking -2, and we're putting it, we're putting it right there in place of that x. Basic math, what's 2 times -2?
-4.
What's -4 plus 5?
1.
What's the square root of 1? What's 1 minus 7? So you just do all that math and make sure that the left side and the right side match each other, which they do, and therefore -2 can be boxed up as an actual solution. Okay. Any questions so far? Okay. On the third problem, our third example, the idea of, quote, get the radical by itself isn't really going to be so much applicable. You'll see it's actually a very simple problem. The square root of 5x minus 1 equals the square root of x plus 7. So, you know, it's our third example, and we haven't seen one like this yet, but there's really, like, there would be no sense in trying to bring the radicals together. You can't add and subtract radicals like that. They don't work that way. So I'm going to, just leave it like this and just square both sides. I mean, why do anything else? So when I square both sides, the radicals just lift off, and I'm left, again, instantly morphing into a very simple math problem. 5x minus 1 equals x plus 7. And then from here, you do what you do. You pull your x's to one side and get 4 of those bad boys. You add the 1 to the other side and get 8. You divide by 4 and you get x equals 2. And before you box it, you got to vet it. Make sure, check this, do a little background check on this thing. So we're going to take 2. We'll start by putting it here, and then we can put it here. And if the left side equals the right side, then I'm going to be happy. So what is 5 times 2?
10.
10 minus 1,
9.
square root of 9. So the left side equals 3. Let's check the right side. What's 2 plus 7? Square root of 9. 3 equals 3. I'm happy. We're good to go. So that's 3 in a row. Let's take a look at example number 4. I have the square root of 2x minus 4. And then after the root, plus 11 equals 7. Some people who, I don't know what it is, if it's poor listening or I don't know what it is, but some people would just go, I'm gonna square both sides. And of course, that's not smart. We want to subtract that 11 first, right? And so we're going to take the square root of 2x minus 4, and we're going to set it equal to 7 minus 11, which is -4. Right. And this is where you see why things happen the way they happen. I made a little comment earlier that sort of alluded to this or foreshadowed this, that what happens to a negative number when you square it? It becomes positive, and that's going to pose a problem here. So if we follow the normal steps and we square both sides, square this side, Square this side, and we're left with 2x minus 4 equals positive 16. And then you just solve. You add 4, 2x equals 20, divide by 2, you get x equals 10, blah, blah, blah. And then you go plug it back in, because that's what you do. And you take 10, and you go put it right there. Yellow circle goes to yellow circle. What's 2 times 10?
20.
20 minus 4?
17.
Square root of 16. 4 plus 11. 15 does not equal 7. Therefore, this is not a solution. I would cross it out. And because it was my only candidate to be a solution, then there is no solution. This is going to be a very uncommon occurrence for this introductory level of these radical equations, but I want you to be aware that it is a possibility. So, next example is the square root of 4 minus x is equal to the square root of x over 3. I'm just trying to check every box, like, okay, things you need them to know before you set them loose to work. Fractions. I don't know why it causes people such misery, but it just does. And so step 1, though, is still just to square both sides, right? You got a root equal a root. You just get rid of those darn roots. So if I square the left side and I square the right side, I'm left with just basically the same equation. And then you get this. What do you do, Tanner? That's what I would do. People don't like fractions, and it's always so interesting to watch them struggle, because it's like, well, why not just get rid of them? Just multiply by 3. It doesn't get you any closer to solving the equation, but it sure does feel nice, because then there's no more fractions. So if I do a times 3 around this entire equation like this, what do I get?
You get 12 minus 3x.
Mm-hmm. And then at this point, good fundamentals ought to tell you what to do. You add the 3x. Yeah, you do enough math and you just start to understand how this all works. You have to segregate. That's what solving linear equations is all about. You have to get the variables onto one side and the numbers on the other. No one cares which is which, but they do need separated. And so that's why we would add the 3x and we'd get this, and then we would divide by 4 and we would get this. And then of course we would take a quick moment and vet it. So you take your 3, he's your candidate, and you go back and you put it up in the beginning of the problem, and that would go here and here. What's 4 minus 3?
1.
Square root of 1?
1.
So I get 1 equals, and then what's 3 divided by 3?
1.
Square root of 1 equals?
1.
1 equals 1. Last I checked, I can box this dude up and sleep well tonight. You guys okay?
So when you multiply by 3, you multiply to x.
Everybody. Well, oh yeah, of course. You mean, are you referring to this x right here?
Yeah.
Yeah, because it's just distribution. That's what the big parentheses are for, is it goes there, it goes there, and it goes there. Right?
All right, yeah.
Okay. Next example. Like I said, I'm just trying to check every box here. I sometimes don't accomplish this, but I want it to be like, okay, here's your worksheet. You should encounter nothing you don't understand. So divide by -7. There are still people among us who would add 7, and I need to just say, if you catch anyone like that, you should give them the what for. If they're a friend of yours, you should get on them, right? We know that that's not a -7, for God's sake. It's a -7 that is multiplied, and the only way to remove something that's multiplied is to divide. So we get 7 equals the square root of 7x, and then the same steps go. Same steps from here. Square both sides, you get 49 equals 7x. Divide both sides by 7, you get x equals 7, and then you vet it. Background check that little son of a gun. Put him back up in. Does he work? Put 7 back up in the original equation. It's hard to fit all this on the screen, sorry. So this is my answer, or so I think, and I'm going to put it up here in place of this x. Just work the math out, dudes and dudettes. What's 7 times 7? What's the square root of 49? What's -7 times 7? And -49 equals -49. Last I checked, you, sir, are a solution. Right? 2 more examples, each one serving purposes again. So we have -32. equals 4 times the square root of 2x. What do we do? Tenemos que dividir por 4. Negativo 8. Yeah, this is where you see the funk happening, right? You see it, you feel it, you smell it. You're like, I'm about to square a negative number, and it's going to become something that maybe it wasn't originally intended to be. So when I square the left side and I square the right side, this is where the funk happens. I get 64 equals 2x. Divide by 2, x is 32. Everything's fine, right? Problems? So you take your 32, you put it up here. What's 2 times 32? Square root of 64. 4 times 8, which last I checked, negative 32 is certainly not the same as positive 32, meaning yet again, no solution. And one more example, and I just wanted to do this one just because there's something in the equation that high school people. Yes, correct. And the reason for that, and I'm careful not to teach it that way, but the reason is that square roots we take what are called principal square roots. And so like if someone says to you, what's the square root of 16? What would you say? 4. Would you ever say anything else? Only if we want the positive and negative, but the principal square root is always the positive version. So the square root of anything is never going to be negative. So yes, Josh, that's right. I just don't want to go down that road because someone later on down the line is going to see a problem like this. And this is where it comes back to haunt me. And then they go, wait a second, you said if there's a negative, there's no solution. And that's why I do not teach it that way. But if you understand in what context that's accurate, then you're fine. So that's why I don't ever go there. I went there just now, how ironic, but no, just do the work. So our last example is the square root of negative 4 minus x equals 3. You might wonder, like, gosh, this feels just like a warm-up problem. There's just something about the what happens that after we square it, I don't know why. Square, of course, we square both sides and we get negative 4 minus x equals 9, right? I was your algebra teacher for most of you a couple of years ago, for a couple of you last year. And I think that, no, I think that math can be so easy if we take a clean look at what the math gods are trying to tell us. I don't look at an equation like this and think about all fancy stuff. Here's what my brain does. I hate negative x, so I throw it over the equal sign. And what does it become? Positive. And this happens all in your head, right? So I move it over, it becomes positive, and then if it lands over there, then it's like, hey, 9, I am now taking this side over, you go to there. And again, it all happens mentally. Poof. What do you get? Say it again. Yeah, you get x equals negative 13. So I just wanted you to see in an instance like that. Is that the only way to do it? No, you could have added 4 and divided by a negative. I don't give a rip. I just think that in a case like that, it's important that you understand that doing some good mental math is sometimes pretty cool like that. So go ahead and vet this real quick. If I put negative 13 right here, oh boy, here it goes. Negative 4 minus negative 13. Pause very much on purpose. Is negative 4 plus 13, which is positive 9, whose square root is 3. 3 equals 3. He's a solution. Got it? Any questions?